Okay, hello everyone, welcome. Can you hear me?
Yes.
Okay, thank you. Just we are waiting 1 minute, then we'll start. Okay, hello everyone, welcome. Today is our second day's online training program. So I hope all of you already get the previous recorded video classes and also get all of materials for practice code you can already get. Okay. So after completing the 3 hours live training, then we talk about the problem solving class. Okay, if you have any problem, then you can simply share your screen and then show me your problem. Okay, after completing the 3 hours live training, then we talk about the problem solving for our 1 hour. Okay, so let me share my screen. Just a minute. Okay, can you see my screen? Okay, thank you. So let's go. So basically today's session I discuss about that how to filtering and displaying the satellite images, Landsat, Sentinel or Modis or any other satellite images, how we can easily filtering and displaying, as well as how we can easily apply the different types of satellite composite, how to apply different types of band combination, and then how to export the satellite imagery, and then how to import, filter, reduce, clip, and display any raster data in Google Earth Engine. We also discuss, as well as we also discuss about the time series analysis, mainly using the ready-made dataset, how we can easily apply and make the time series analysis. We also discuss, and how to export any shape file from Google Earth Engine. We also discuss about that, and also discuss about the annual image composite, how we can easily make the annual image composite. So let's go step by step. I will try to complete all of topic. Then I hope you can easily get the idea. So let's go. So we already know about that Google Earth Engine. Mainly, it's a cloud-based platform, and everything will be controlled from the cloud. And we don't need to download any kinds of data set because we can easily find out all of data set in the cloud. Okay, we can easily find out all of satellite image collection, Landsat, Sentinel, Modis, or different types of trained data set, SRTM dataset or ASTER-DEM, or different types of land cover dataset or atmospheric dataset, we can easily find out in the Earth Engine public data catalog. So from this data catalog, we can easily get all of dataset. So this is the best benefit to using the Google Earth Engine. You don't need to download any kinds of data. So you can easily get all of satellite imagery from the Earth Engine public data catalog. And this type of dataset daily updating And in the data catalog, we can easily find out more than 200 public data set, more than 4,000 new images every single day it provide, and more than 5 million images and more than 5 petabytes of data we can easily access from the Earth Engine public data catalog. And this is the link about that Earth Engine public data catalog. We can easily access all of data set from this link. Or if you want, you can simply open your code editor. From this code editor, we can also access all of data set. So this is the code editor. Click on the search place. You can see the browse data catalog. Click on here. So now we can easily find out all of Earth Engine public data catalog. If this is the main page. So here we find out the all of data set, climate and weather data, surface temperature, climate. You can see the atmospheric data, weather data, different types of imagery, Landsat, Sentinel, MODIS, or high resolution imagery for a specific country, as well as geophysical data. You can easily find out different types of terrain data, land cover data, agriculture data, other geophysical data we can easily access from this Earth Engine public data catalog. As well as you can see the Landsat. So when you click the Landsat, then you find out all of Landsat collection, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of image collection for Landsat we can easily access. Click on the Sentinel. So then we can easily find out all of Sentinel image collection, Sentinel-1 SAR data, Sentinel-2 multispectral instrument data, Sentinel-3 ocean color, and then Sentinel-5P tropomy data, tropospheric instrument. So all of data we can easily find out from here. Also click on the MODIS. So then we can easily find out all of MODIS image collection, different types of MODIS product we can easily find out in here. Okay, so now how I can use this type of data, Landsat, Sentinel, or MODIS in here. So let's go step by step. I'll try to show you that all of data set. So first of all, Landsat. So here we find out the Landsat collection 2. So here we find out that Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So basically when you filtering this type of data for your study area, all of image collection for Landsat 9, Landsat 8, Landsat 7, Landsat 5, 4 and 1 to 5, all of are the same process when you filtering your dataset or export your dataset. All of filtering process is the same. Okay, so Landsat 9 is available between this time period 2021 to present time, Landsat 8 2013 to present time, Landsat 7 is available between this time period, Landsat 5 is available between this time period, Landsat 4 is available between this time period, and finally Landsat 1 to 5 it's available from 1972 for 1999 from this time period. So this type of image collection, how I can filter and displaying in the Google Earth Engine, we also discuss about that, and how to export this type of satellite imagery. So let's go step by step. I try to explain, then you can easily get the idea. So when you filter your satellite imagery, so this filtering process is different some factor. So first factor, it's your region of interest. Suppose where you need the image. So first, this is the first factor, where you need the image. Suppose I need the image in the Dhaka city. So Dhaka city is my study area. So first of all, I need the Dhaka city boundary. Okay, so this is the first factor for filtering. So when you filtering your image collection, it can be Landsat or Sentinel. First factor is that you need your boundary, your shape file. So suppose I need the satellite image for the Dhaka city boundary. So this is my first factor for filtering. Second factor, filtering image metadata. Suppose I need the image. This image will be not more than 1% cloud cover. So I want to need only for those images, which image will be not more than 1% cloud cover. So this is the another factor for filtering. Third factor, for a specific time period. Suppose I need the image in year of 2017, summer season, rainy season, or any specific year or any specific season. So this is a third factor. So always when you filter your satellite image collection in Google Earth Engine, we just filtering using the three factor. First factor is the region of interest, mainly where you need the image. Second factor is that your specific cloud level, or filtering image metadata, or filtering image properties. Suppose I need the image only less than 1% cloud cover. It will be not more than 1% cloud cover. So I filtering image properties. So this is my second factor. And third factor, suppose I need the image in year of 2017 month of January, or summer season, rainy season, or any specific time period. So using this three factor, we always filtering our image collection. So let's take the practical example, then you will get the more better idea. So let's go. So first of all, I want to work with, suppose this all of are the same process, Landsat 9, Landsat 8, 7 are the same process. Okay, so I will show you for suppose Landsat 9. Click on here. So here we find out this type of reflectance. First one, you can see surface reflectance, top of atmosphere reflectance, and also raw image. So basically top of atmosphere and surface reflectance, this type of image collection is already atmospherically corrected. Okay, already atmospherically corrected, this type of surface reflectance or also top of atmosphere. So when you are using this type of collection, surface reflectance or top of atmosphere reflectance, you don't need any kinds of correction. Okay, so if you work with suppose USGS website, we also download also image, satellite image from this site, USGS Earth Explorer. So when you download this imagery from this website, then we need to correction, different types of correction we need, atmospheric correction or enhancement we need. But when you download the satellite imagery from surface reflectance or top of atmosphere, so they are already done all of correction. So then we not need to put any kinds of correction for when you are using the surface reflectance or also using the top of atmospheric reflectance. You don't need any kinds of correction, because you can see it's already corrected, atmospherically corrected surface reflectance. Okay, so both are the same process when you filtering. Suppose I want to show you for that suppose top of atmosphere, just click on here. So now I find out all of information about this Landsat 9 top of atmospheric reflectance satellite imagery. So you can see this imagery is available between this time period. Okay, and this is the dataset provider. It's provided USGS and Google. So they are provide this data, and this is the snippet ID. Okay, this is the Earth Engine snippet ID, or this is the directory of this dataset. Okay, suppose this directory, you can see first of all it's the name Landsat, then version Landsat 9, collection 2, tier 1, top of atmospheric reflectance. So this is the directory of this data set or of this image collection. This is the directory. So now this is my unique ID. Okay, this is the unique ID. So basically this unique ID stored the full image collection. It stored the all of images in this directory. As well as you also find out this type of information bands. You can see band 1, band 2, band 3, basically coastal aerosol, blue band, green band, red band, and infrared band. So different types of band also find out. So now this is my image collection, or this is my data set. This data set I need to import in my code editor. Okay, so how I can import? It's very easy. Just you simply copy this snippet ID. Every image collection we find out this type of unique ID. Every data set we find out this type of Earth Engine snippet. Basically this snippet is stored the full data set. Full data set is stored in here. Just I copy and then paste in our code editor. So now just take a variable name. Okay, we can put any variable. So just store this image collection in a variable. So you already know about that. Before the variable name, we are just use the var keyword for JavaScript and put the variable name. Variable name can be anything. You can put any name as a variable. Suppose I put the name L9. You can put any name. So now this image collection is stored in this variable. Okay, or this image collection is stored in this folder. So now I want to check how many images stored in this folder or in this variable. How many images I want to check it. So for that, just print L9 and use the size function. Okay, so size function computed how many images are available in this collection. Okay, so let's go try to run it and check what happened. So now you can see it show the number computing. Basically, it computed how many images are available in this collection between the time period 2021 to 2025 06 20. Okay, between this time period, how many images are available in this collection? We try to check it. And if you check another way, suppose just click on the docs tab and simply search, find out the image collection function. If you check, and we already know about that image collection is one kind of data type. So previous class I discussed about that. Basically find out the total 5 types of data in Earth Engine. Okay, so image collection is one kind of the data type. So you can see ee.image collection. Okay, ee.image collection. So now all of function, you can see in the sub function, all of sub function I can apply in the image collection. Okay, so if you check size function, what is the size function? You can see size function, what is the size function, you can see. So now I just use the size function to check how many images. So you can see the description, return the number of element in the collection. Okay, so how many element or how many images are available in this collection, we can easily check it using the size function. Okay, so this size function, you can see it's available in the section of image collection. You can see it's available in the section of the image collection. This is the section of image collection. So this is the header. So just click on here, you can find out the sub function. Sub function, you find out the size. So this size function is always work in the image collection data type. If you want to apply it for other data types, then it will not work. Suppose I have an image, but I apply the size function, then it will not work. So further I will explain more details about that, then you can easily get the idea. So now we find out this is the total number of image collection. It is stored in this variable. So now this image collection I need to filter. Okay, and how I can filter? I want to filter using this factor, using this 3 factor, just I filter it. Okay, so first factor is the study area, mainly where you need the image. Suppose I need the image in the Dhaka city. So here I already imported the Dhaka city boundary shapefile. Previous class I already discussed how we can easily import our shapefile boundary in asset tab. So here I already imported Dhaka city boundary. So let me import in the code editor. Okay, so this is the Dhaka city boundary. Here I already imported. Just I click on here, you can see it will be imported as a table. It's a default variable name. We can put any name as a variable. Okay, suppose I put the name as a RY. Okay, so now I find out this is the image collection for the whole world between the time period 2021 to 2025. But I don't need for the whole world. I need only for my study area, Dhaka city boundary. So if you want, you can also add the layer of your shapefile. Suppose this is my shapefile boundary. Just I add a layer, RY, and also focus on the given study area. Just focus using this function. We already know about that. Just I focus. So this is my study area. So I need the image only for this study area. Only for this boundary, I need the image. I don't need for the whole world, but this collection, it show for the whole world how many images are available for the whole world, but I don't need for the whole world. I need the image only for my study area. So for that we just use a function. This function, if you check from here, this function, it's called the filter bounds function. You can see filter bounds function. So what the description, you can check it. So you can see filter bounds function, shortcut to filter a collection by intersection with geometry. Okay, so in this case, this is my geometry and this is my collection. This is my collection. So I want to filter this collection by intersection with this study area. So let's go try to apply this function and then check what happened. For that, just take a variable. I put the variable, you can put any name as a variable. You can put any name. I put the name, suppose filter region, filter region. So now this large number of image collection, it is stored in a variable. You just find out the variable name, mainly this variable. This variable is stored this image collection. So now I want to filter only for those images which are available in my study area. So for that we are just use the function filter bounds function. And what is the argument? Argument is the geometry. Okay, and what is the geometry? Geometry basically it's a feature collection or geometry or computed object. Okay, so the geometry or feature or collection to intersect with. So I want to use it filter bounds, and then my geometry is that ROI. So just put here the ROI. So now let's check how many images are available in my study area after filtering the boundary. Just print, use the print and call this variable filter region and apply the size function. So now it's computing how many images are available in the Dhaka city boundary. Find out. So we find out 143. Okay, so for this study area we find out 143 images between this time period 2021 to 2025. Okay, but I need only for those images less than 1% cloud cover. Suppose from 143 images I just choose only for those images which image will be not more than 1% cloud cover. So I want to filter image metadata or image properties. So for that we need to use the function filter metadata. If you check filter metadata function you can see, so shortcut to filter a collection by metadata. Okay, so just we are use it and you can see name, operator and value. So what is the name? Name mainly image property name. Okay, which property you want to filter, just put the name. Then operator, you can see different types of operator, equals, less than, greater than, not equal. So this is the operator. And value, we can set the value less than 1%, 2%, 3%, what you need. So just I copy this function and then take a new variable. You can put any name as a variable. Suppose I put the name filter metadata. Okay, and then call the filter region because this variable stored this 143 images. I want to need less than 1% cloud cover imagery from 143 images. So just I call this variable because this variable stored this image collection. Okay, so now just apply it, filter metadata, then name, operator and value. So what is the name? Name, it's come from image property. You can see the image properties. So I choose cloud cover. Just I copy the cloud cover and then put here, and then operator. I set the operator less than and set the value less than 1. So now in this variable store it only for those images which image will be not more than 1% cloud cover. So let's check. We try to print how many images are available. Just copy and check using the size function how many images are available less than 1% cloud cover. We find out the 29 images. Okay, so we find out the total 29 images are available less than 1% cloud cover for this study area. And what is the time period? This time period 2021 to 2025, between this time period we find out that total 29 images less than 1% cloud cover. But I don't need for the whole time period. I need it for a specific time, summer season, rainy season, or any specific time. So for that we are just use, you can see filter date function. Okay, filter date. So filter date function shortcut to a filter a collection by date range. So we simply put the any date range and then we try to filter. So start date and end date we just define. So let's go try to use it. Take a variable, suppose filter, I take a variable name, suppose filter date. You can put any name. So now from 29 images, just I copy this variable because this variable stored 29 images. Okay, just paste here and then apply filter date function and then put the date. Suppose I need the image in year of 2024 1st January from year of 2024 December 31. So I take the 1 year imagery. Suppose 2024 January to December, I just put in here. And now print. So now let's check how many images are available in this time. Just use here the size function. And now run the code. So now it shows the result. So we find out the only 4 images. Okay, these 4 images are available between this year, and this 4 images is the less than 1% cloud cover. Okay, if you want, suppose I just increase the cloud level, then you can see what happened. Suppose I increase cloud percent less than 10%. So now my image collection is also increased. Again, so you find out that less than 10%, 44 images are available, and between this time period we find out the 6 images is available less than 10%. Suppose I put here that less than 50%, then you can check it also more increased. We find out that less than 50% is the 93 images, and then 27 images is available between this time period. Okay, so this is the cloud level. Suppose if I put here that 100% cloud, then check what happened. We find out the 140 images are 100% cloud, less than 100% cloud, and then 39 images is available between this time period. So we always try to keep lower cloud level to get very neat and clean satellite imagery. So we put here the less than 1%, because less than 1% is available for my study area. But sometime when you work with coastal area, or when you work with river bank, or when you work with any place, there are always cloud formation. There's a lot of cloud all time. Then you don't find less than 1%. Then you need to increase the cloud level 5%. 5% is not available. We find out the 0. Then you need to increase the 10%, or then increase the 20%, or 30%, or 50%. Okay. But if first time you try lower value, suppose 1%, it show the 0. It show the 0. There is no image. Then you need to increase the value 2%, 3%, 4%, 5%. Okay, then we find out the value. So basically we find out in the cloud in the river bank area or coastal area, we find out the very high cloud. Then we need to increase the cloud level. Otherwise it show the null value or 0. There is no image. Okay, so now I find out the total 4 images between this time period 2024. This time 4 images I find out in here. And you can see this is the process for filtering. Okay, so first time I find out this is the large number of image collection. This image collection is available for the whole world, but I don't need for the whole world. I need only for my study area, which is ROI. So where you need the image, for that I just put here filter bounds function where you need the image. Then from 143 images, I just choose only for those images less than 1% cloud cover. We find out the 29 images. So how you need the image? So I need the less than 1% cloud cover, and then from 29 images I need only for those images in year of 2024 January to December. Okay, we find out the 4 images. So when you need the image. So basically higher, how and when. For the higher, you are just use here the filter bounds function, it intersecting with your study area. Then how basically filtering image metadata, I need less than 1% cloud cover. Or when mainly when you need the image. For the when, just use the filter date. And how, for that just use the filter metadata. And where you need just put here the filter bounds function. Okay, so this is the process for filtering, and this same process we filter all time for any other image collection. It can be Landsat, it can be Sentinel, it can be Modis, anything. Okay, so now I want to check all of information about this 4 images. All of information I want to check for the 4 images. So for that, just print filter date and run the code. So now it show that all of information about the 4 images. So you can see the 4 element, basically 4 images we find out in here. And every image have total 17 bands. If you check information, you can see the features. So first image, you can see this is the first image. Just click on here. We find out, you can see this type is the image. Okay, so image is one kind of data type. We already know about that. So image is one kind of data type in Earth Engine. And if you check, this is the ID and click on the properties, then we can get all of information about that. You can see this is the cloud cover for the image. Okay, you can see the image acquisition time. So this is the acquisition time about this image. So all of information for the image we can easily get for this, for the first image. Then second image, just click on here. So we find out this is the second image. So click on the properties, so we can get all of information about this image. Okay, then suppose I want to check for third image. So this is the third image, then this is the fourth image. So we can easily get all of image information from here. So now I want to add the one image. Suppose I want to add this image. I want to display on my map. Okay, this image I want to display. So for that, just copy this ID. Just copy this ID. Okay, just copy this ID and then paste here. Okay, so now just I paste here this ID, but I want to define a function. Okay, so if you check, this data type is the image. Okay, this data type is image. So I want to simply search a function from image section. If you check image section, ee.image, so it's an image section. Click on here. So you can see the first function ee.image args. So an object to represent Earth Engine image. This constructor expect a variety of argument. So now we try to apply the string Earth Engine asset ID. You can see now I have a ID. So this is the ID. This is the ID. So just I use it ee.image function. Okay, and then use this ID. Okay, I have already this ID. Just I paste here and also close the bracket. Close the bracket. So now I just use this function ee.image and define the ID. Define the ID. So now this thing just store it in a variable. Okay, you can put any name as a variable. I put the variable name, suppose image. Okay, so now this image is stored in this variable. So I want to display it. So just add a layer and then put the image and run the code. We find out this type of image, you can see, but this image, it's not fully fill up my study area. You can see some area is missing. You can see this type of part is missing. Okay, basically this tiles is not fully cover my study area. So then how we can do fill up it? So for that, you try to check the another ID. Suppose another ID, we try to check another image. Suppose let me check it for this. Just copy and then remove the previous ID. Just paste and run the code. So now let's check what happened for that. Okay, it's fully fill up my study area. So then I can easily use this image. Okay, so now you can see it show the image for the full as a tiles, but I want to display the image only for my boundary. So for that, we are just use a function. This function called the clip function. Okay, and if you check in the section of the image, you can see the ee.image. So we find out the one function. It's called the clip function to clipping your image. Clip. Okay, you can see the clip. Click on here. So clip an image to a geometry or feature. Okay, now I have a geometry. This is my geometry and this is my image. So just I use the clip function. So let's go and try to clip. If you just use the clip function in here, dot clip, and then put your geometry or feature shapefile variable name. Okay, so my shapefile variable name is ROI. So just I write here ROI and run the code. So now it's just clipping with this boundary, and we find out the image look like that. So now it look this type of dark color. So how I can add the visualization, different types of band combination. So for that, you can click on the setting layer properties, and we can see different types of band. You can see, if you want, you can also show the band, one band also as a grayscale. We also try to show, but I want to create the band combination, mainly 3 bands, create the one combination. So I want to add, suppose, red band, then green band and blue band, mainly RGB, red, green and blue. And stressing is one kind of data visualization process. So if I just put the stressing 98%, so now this data is stressed and show this type of mean and max value for the reflectance value. This is the mean, this is the max reflectance value. And if I just apply, so now it also add this type of natural color band combination you find out in here. Okay, so you can see, find out this type of things. So it's one kind of satellite imagery. It's a natural color or true color. So now this visualization I need to import in my code editor. Okay, so for the import this visualization parameter in the code editor, just click on the import button. So you can see it will be imported, and it show this type of variable name. This variable name just copy and paste after the object name. Okay, then you put the layer name. Suppose put the layer name is that, you can put any name. Suppose I put it's a true color. Okay, so now this visualization is set it with my imagery. Yeah, any question, anyone, please? Yes, so for image is also covered, but further we need to create the composite. Okay, so I also discussed about the composite after some time, how we can easily create the composite. So in this time I talk about the single date imagery. Suppose it's a single date imagery. Suppose in this time, this imagery acquisition time, if you check, we find out this is the image acquisition time 2024 of 1st March. Okay, but if you want, you can combine all of images, then we can create the median composite or mosaic composite, then use the 4 images. Yes, please, any question? Yes, any question, anyone, please? So I'll discuss about the composite after some time, then you can easily get the idea how to create the mosaic and how to create the composite. Yeah, please, any question?
Yeah, when you are filtering the data by region, is there a way you can be able to just filter to get images that completely cover your area? Eliminate those that cover partially your area.
Yes, so in this time when you work with suppose big study area, so big study area, one tiles or one image is not covered, fully fill up. Okay, suppose I need the satellite image for the whole country boundary of Bangladesh. So then one tiles is not fully fill up the big study area. Then we need to create the composite. Okay, median composite or mosaic composite. Then we need to create. But when you work with a small study area, suppose this type of a small study area which cover the one image or one tiles, then we can easily use this type of things, because different types of analysis we also need the single date imagery. So I will show you the both of process, how to work with single date imagery, how to work with composite for mosaic composite, or how to work with median composite. Then I hope you can easily get the idea, no problem. Yeah. Okay, so now I just add one kind of band combination in here. Suppose I want to add the another band combination. So for that, just click here again. I want to add, suppose, near infrared band, then red band, and keep the blue. Stressing I keep 98%, and then apply. So now it added the another band combination, this type of color we find out in here. And now this visualization I want to import in the code editor. So for that, just import. You can see a new line of code will be added in my code editor. So I want to add the another layer for this visualization. So for that, you can simply just copy and then just copy the variable name. Okay, I put the layer name, suppose it's a false color. So now it creates another layer for another band combination. Suppose I want to add the another one, just click on here. Suppose I want to add the band combination for short wave infrared one, then near infrared and green. Apply. So now you find out this type of band combination. Just import. So I want to add the layer, so that I copy the same line of code. And then copy. And paste. You can put any name. Suppose I put it's just used for agriculture. I put it and run the code. So we find out, you can see it's agriculture, it's a false color, it's a true color band combination. We find out. So this is the work for the single date imagery. Okay, so any question about it, you can ask me, please. Yes, please.
So we have a time frame like from January 1 to December 31st.
Yes.
So from this image, what actually we are finding that
Okay, it's single date. It's just only for this date. Okay, one date image, one day. Okay. But we find out that total number of images between this time period, 4 images. Okay, but now we just displaying only for the one image, single date, one imagery. Okay,
So I would like to ask, how can we get an image or a picture using coordinates, specific coordinates, instead of writing the name of the country or maybe state or directly the place? So how can we get the picture of a place using coordinates?
okay, so this coordinate, first of all, you need to import in the Earth Engine, or if you want, you can also just take the, you can see geometry. Okay, just click on here, it added the geometry. Okay, suppose I need the image for this point, for this study area. Okay, so for that you can simply work with that, just simply use it's your ROI. So just use your ROI or put the geometry, then it will work. Okay, suppose this is my study area, so I need the image for this study area. So how I can do it? So just I put here, this is my, okay, I put the geometry, this variable I keep the same, simply change it. Oh, I need the image in the geometry, and also just I comment this type of things, and now run the code. So now for this study area, how many images we find out, we can check. we find out the 4 images look like that. Okay, I want to change it geometry. So now you find out this 4 images also in here. So now I want to display this imagery. Okay, so for that you can simply copy the suppose I just display for this specific date or single date imagery. Just copy, suppose this is my ID, just I copy and then change it and paste here. Okay, so now we easily find out the imagery for this study area or for this coordinate. Just run the code.
Should we change the clip ROI to clip geometry?
It also need to change. Okay, it's not need, because in this time we focus for this boundary, for this point. Okay, it's a point. So now you can see it also covered this point also. Okay, or any area. Suppose I need the image for another study area, I will show you that. Suppose I need the image for this, for just I press and drag it. Suppose I need for this for here, so just run the code. Okay, so now you can see here we find out the 11 images. Okay, just I copy the imagery. Suppose I just copy, I want to show the first imagery. Just I copy this ID, just copy this ID and change this ID. Just change it, because this ID for this area I want to change the study area. Just run the code. So now you find out the image for our point, which I set the our point. You can see this area. We find out, you can see these tiles we find out in here. Okay, so now this is the imagery we find out for this ID. Okay, for this location. So when you work with single date imagery, all time we need to change this ID, otherwise it's not work. Suppose if I just need the image for another study area, just I copy, suppose this study I need the imagery, and just run the code, and you can see it show the new image, new ID again for this new area. Okay, so for that I need to copy the image ID again from here. So which date you need, just copy. So you can see different date we find out in here. Just I copy and change the ID. Again change the ID, because I changed my area or changed my location. Just run, click the run. So now you find out the image for this point which I put here. Where? Yeah, this area. So you can see, find out the imagery in here. Okay, because for this area between this time 2024 27 March we find out the image look like that. Not only for that, if you need the another imagery, so you also check the image time, all of image time for this area. For this area all of images are available, all of image is available for this area. So from here you can check the time. From here which time you need, just copy this ID, just copy this ID. Suppose I need the image this time to 21 October. Okay, 21 October, just I copy and then change it and paste here and run the code. So now you find out the image for 21 October. So if you check, we find out this type of imagery. Okay, and this is the different types of band combination you can find out. So this thing you can also do not only for the point. Suppose you can also do it using a you can draw the different types of geometry. Suppose I need the image for this area. So I simply draw my study area. So this is my geometry. So now if I run the code, we can get the image for this geometry. You can see we find out this type of geometry, and I need only for this study area. Okay, other image I don't need, I need only for that. So then you can just simply use here dot clip function, dot clip with your shapefile variable name. In this time this area is stored in geometry. Just copy the geometry and then paste here. Just use the clip function and run the code. So now we find out the image only for this boundary which I selected in here. Okay, and what is the image acquisition time? So this image acquisition time is the 21 October. Okay, it's a single date imagery. Okay, so any study area we can easily find out. So this is the process for single date imagery. Basically different types of analysis, we also use the single date imagery. Okay, but now I talk about the how we can easily create the median composite, or how we can easily create the composite. And composite, when you need, suppose you want to work with a big study area. Suppose I need the image for the whole study area of Bangladesh. Okay, suppose I will show you the example. Suppose I need the satellite imagery for the whole country boundary of Bangladesh. Okay, so now all of single date imagery is not possible, or one image is not fully fill up my whole study area in Bangladesh. It's not fully fill up. Then we try to apply here composite. Okay, suppose let me import the study area of shapefile for Bangladesh. Suppose just I import. So it's a Bangladesh boundary shapefile, and I want to use as a suppose BD. Okay, so now BD is my study area. So I need the image for BD. So just I put here BD. Okay, filter bounds with BD. BD is stored the Bangladesh boundary shapefile. So then, okay, now let me run it. So now we find out how many images are available in the BD. Whole country boundary Bangladesh, we find out how many images. We find out the 58 images. Okay, so we filtering, we find out the total 58 images are available in the whole country boundary of Bangladesh. Okay, because in this time you can see I just use the BD function. Okay, BD basically it is stored at the Bangladesh boundary. Okay, so then I filter less than 1% cloud cover, then I filter a specific year 2024. So we find out the 58 images. Okay, and if you check all of information for single imagery, all of 58 images, we can easily get all of information, all of images. So from here you can easily display one single tiles, and this tiles is not fully fill up your study area. If you check, suppose I just copy, I want to display this image. So just I change it. Okay, just I remove the clip and run it. You can see what happened. So now it show the tiles. It show this tiles. Yeah, this type of tiles we find out. And this tiles is not fully fill up my study area because I want to work for the whole country boundary of Bangladesh. But now this tiles is only fill up for this area. Okay, this tiles. And you can see what is the acquisition time for these tiles. This is the acquisition time. 1st March we find out. So now single date imagery is not work for the big study area. So then we talk about the composite. So let's go how I can create the composite. Okay, so now I have total 58 images. So I want to use all of images and create the one composite. So we can create the different types of composite if you check the image collection function. So if you check, okay, let me show you that median. So this is one kind of median we are just use and create the median composite. So basically it reduce an image collection. Okay, so I have a image collection 58. So when I apply the median, then it reduce the image collection. How? Calculating the median of all values at the each pixel. Okay, across the stack of all image meshing bands. Okay, so it create the median value each pixel. Okay, mesh by their bands. So when I apply the median, so it create a median composite image. Not only for that, if you check another one, mosaic. Okay, so basically median and mosaic is very popular, and median, this function is also help you to remove the cloud, okay, on unnecessary pixel, it automatically remove or filtering the noisy pixel. When you apply the median, it's create or automatically remove some noisy pixel. So let's go try to apply the median function and create the median composite. And how it create the median composite, calculating the median of all values at each pixel across the stack of all meshing bands, and bands are matched by their name. Okay, suppose near infrared band, red band, blue band, like this. So now I want to use it median. So let's go. So for that, just take a variable. I put the variable name, suppose final image. You can put any name. And now this 58 images is stored in a variable. Okay, this variable name is the filter date. Just I copy and paste, and then apply the median function. So now what happened? So now I have a collection 58. So this 58 images middle pixel value create this median composite. Okay, so now if I just show the layer, suppose just add the layer, map.add layer, and call the final image and run the code. So now it create one kind of median composite which cover the full study area of Bangladesh. It's loaded. So you can see it's fully cover my study area, look like that. Okay, but I need only for my area. Okay, so for that, just simply use the clip function. After median, just apply the clip function, clip with study area bd, just run the code. So now we find out the image only for our study area in Bangladesh. Okay, so now if you want, you can also add the different types of band combination. Same process, click on here, and you can add the different types of band combination and display your imagery, median composite imagery. Suppose I want to apply for near infrared, then red and blue, RGB. I keep 98% stressing level. And then apply. So we find out this type of image collection for the whole Bangladesh country boundary. So now if you want, you can use it and make the different types of remote sensing analysis, such as land use, land cover, NDVI, or any other analysis for the whole country boundary of Bangladesh. And this is the process to create the median composite. So in this case, this image is created by total 58 images middle pixel value. Okay, so any question, please?
Sir,
Yeah, please.
what if I have maybe specific coordinates in a specific country and I want to use maybe coverage to cover the only that specific area? How can it be added into the code?
Okay, suppose you have a specific latitude longitude value, yeah, for the point, then how we can easily get the imagery? Yeah, okay, understand. Yeah, okay, so for that we need to import this coordinate in Google Earth Engine. Suppose I'll show you that also, just a minute. Okay, just a minute. So for that, if you want, you can also use here geometry. Suppose I create, so okay, let me show you the one example, a specific coordinate, okay, or lat long. So for that, just take a variable. Suppose take a variable for point. You can bring it in as a variable and apply ee dot geometry 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 dot point. Okay, then you can simply put the longitude and latitude. Okay, longitude first, longitude then latitude. Suppose I put here longitude for Dhaka city, for Dhaka 90.4125, okay, comma, then put the latitude 23.8103. Okay, so now this is my study area. Okay, so this point I want to use as a study area. So for that, you can simply add the layer. So map dot add layer point and run the code. So now it create the another layer for this point. Yeah, so you can see this is the point. So now you can just simply, this is your ROI, it's your ROI. Okay, so this simply just a filter bounds with the point. Okay, then we can easily get this imagery for this coordinate. And how we can easily import the latitude longitude? So ee dot geometry dot point and then put the longitude value and latitude value. So now it's work as a study area. So now it's work as a study area. Not only for that, if you want, you can also create the buffer zone. So for that, use here the buffer area, buffer. Suppose I put here that 1000 or 10,000 meter just on the code. So now it create the buffer. So you can see, find out this type of buffer area. Okay, so now this is your study area. Okay, or if you want, you can just use your point, then simply put here this point and then work with that. Okay, so this is the way we can also take the latitude longitude value, just simply e dot geometry dot point and then define the longitude and latitude value, and then we can easily define our study area. Or if you want, you can also take this type, just click on here and take your this type of things. Okay, then you can also use it as a study area or point. Okay, I hope you can easily got the idea. Any question?
Yes, sorry. How you can add the composite, the median composite into the add layer into the map? With the parameters of visualization. I mean,
Okay, so this is our final composite. You can see the final image. So this is the filter date. Okay, so it stored total 58 images. Okay, so just I call it, okay, 58 images stored in this variable and then apply the median function. So now this median function computed all of middle pixel value from 58 images and create the median composite and store it in this variable. So for that, I want to just add the layer and display this type of imagery. Okay,
okay, but once you put you display in the layers for the red bands, the blue bands, and everything else, and then you want to add the composite into the add layer with the selected bands, how you can do that?
yeah, so for that you can see here. So for that, after adding the layer, just click on here. You can see this is my image. Just click on the setting layer. This is the setting button. You can setting button, just click, then it opens this type of visualization parameter. So from here I simply set, suppose red band, then green band and blue band or any band combination, then stressing 98% I keep, and then it also loading, you can see. Okay, now when I stress 98%, then it is stressing 98% and display the mean and max range. So it is still loading. Yeah, so now it's okay. So then just apply. So when I click the apply, it added the visualization near infrared, red, green and blue or RGB. Okay, it added the visualization. You can see it also added. Okay, it's working. Yeah, it's added. So now this visualization I need to import in my code editor. Okay, So for that, just import. You can see when I click on the import, this line added. Just I copy, and now I want to set with my layer. So for that, you can see map.add layer. So this after the object, we put the visualization parameter. First argument is object, second argument is that visualization parameter, third argument is the layer name. So you can see now it show the layer 2, but when I put the layer name, suppose I put the layer name is a natural color. So now if I run the code, then we can easily find out that layer name as a natural color. Okay, so after the object we always set the visualization parameter. Okay, and it's come from here. When I import, then it will be added the new line of code. Just copy the variable name and then paste here. So now it will be set it. So now you can see we find out this type of visualization.
All right, thank you.
Yeah.
Sorry, I have a question.
Yeah, please.
When do you recommend use median? Because with that step, we were lost the date of the image.
Yes. Okay.
And when do you recommend that?
Okay. So basically, for the median and mosaic, this is the two composite we are always use for the different purpose. So first of all, for the median, it calculate for each pixel across the image collection. It looks at all pixel value through the time and return the median value. Okay, it return the median value, and there's a lot of purpose to use it, such as it reduce the noise. Okay, when we apply the median, it reduce the noise such as cloud or cloud shadow. By taking the middle value or at each pixel, it easily remove all of noisy pixel, as well as it produces at the representative image of your time period. Okay, suppose in this time it's my 1 year imagery, we find out. Okay, sometime it's the year of 2024. Okay, year of 2024, all of less than 1% cloud cover image, it create this type of composite. And also it also suitable for creating the cloud free composite. So you can see this imagery is not mass cloud, it creates the cloud free composite. And basically mosaic, it's mainly mosaic rendered the image collection as a mosaic, where each pixel come from the most recently added image that contains all valid data, and it creates the special seamless mosaic if your image don't overlap mass, and the order matters usually sorted by date when we apply the mosaic. And when you apply the mosaic, it's great for making the seamless image across the tiles or for filling gap. So sometimes we find out the filling gap. Okay, basically when you work with Landsat 7 imagery, then we find out the gap filling. Okay, but then when we apply the mosaic, then it easily gap for filling gap when you apply the mosaic. Okay, so this is the another way. Suppose you try to work with Landsat 7 and you find out some gap. Okay, or you find out the some noisy pixel or dotted line, then you try to apply the mosaic. Okay, then it's easily remove this type of filling gaps with more recent data using the mosaic. Okay, so and this is the way for that. Median is cover your whole year. Suppose when I apply the median, year of 2024, all of images, it's easily covered the 4 year. For the 1 year, it's easily covered. But when you face some dotted line or gap filling, then try to apply the mosaic. Okay. Okay, so I hope you can also get this idea how to work with for that. I'll also show you that also mosaic also after some time. Okay, so now we find out this type of result for the median, but you can check here. I write lot of code for getting the imagery, but you don't need this type of code all time. But first time for your understanding, I just explain all of code one by one. But when you write the code, you will not follow this way. Okay, so I'll show you this way. Just I comment all of line. It's not need now, just I comment. So now suppose I just stored this image collection in this variable. Okay, So now I just add the function filter bounds function with my study area. Suppose I need the image for Dhaka city, so I put here the ROI. Okay, then I put here filter metadata, put here cloud cover less than 1. Then I put here the filter date. I need the image, suppose year of 2020 1st January from year of 2020 December 31. Okay, this is my time period. So now you can see here I just take only for the one variable, and under this variable I write all of function. Okay, all of function I simply put here. Under this variable I put all of function. So filter bounds, filter metadata, filter date. Okay, but first time I just explain one by one, so that's why I write the individual variable, but it's not neat. So just I take the one variable and put the all of function under this variable. So now finally how much image I find out, you can check. 0 image. Okay, so it show the totally 0 image between this time period. Less than 1% image is not available. Okay, let me try for less than 10%. It show that there is no image. Or put here suppose 50%. Also no. Oh sorry, this image, this is the Landsat 9 and it's available from 2021. Okay, but I want to work with Landsat 8. So for that you can simply change the image collection, because it's available from 2013. Okay, you can see Landsat 8, it's available 2013, it's available from 2021. So I want to work for the 2020, then I just use the image collection. So just change it, just copy, and then change the image snippet ID, and then just run the code. So we find out that 7 images. Okay, suppose I want to use all of images. Okay, I want to use all of images and create the median composite. So for that, if I just put here the median and run the code, you can see it show a problem. Okay, in this time this variable size is not work. It show that size is not a function, because size is only work for collection. Okay, size is only work for collection, but when I apply the median function, then this variable is not a collection, it's just a single median composite image. That's why size is not work. Okay, so size is only work for collection. Works for collection, but when I apply the median, then this variable is not a collection, it's just a single median composite image. So that's why it show this type of problem. Okay, so now I just remove the size function and run the code. So now you can see it show the image computing. We find out the image. So this is the median image generated by total 7 images, and you can see all of bands about this image. So now I want to display it. So for that, just add the layer. So just put here map.add layer and call the L9. Okay, and run the code. So now it's added this type of tiles, we find out, but I need the result only for the Dhaka city boundary. So ROI. So just I clip with my ROI. Just use the clip with ROI and run the code. So you find out the image look like that. So if you want, you can also just add the new visualization parameter from here. Just click, and then red, then green and blue. Spacing 98% I keep, and then apply, and also import. So now you can see it also, it show this type of imagery. So just copy and paste after the object name. So this is the object. After the object, we always put the visualization parameter, then put layer name. So I put the layer name, suppose imagery, and run the code. So now we find out this type of imagery. Okay, and it's a median imagery, median composite imagery. Okay, so any question you can ask me. Okay, suppose I want to apply for mosaic. So for that, just change it in here, put here mosaic function. So just run the code. So you can see, find out this type of. So let me add again to get the better visualization. Just stress and apply. So now you find out this type of. It's create the mosaic composite using total 7 images. So this visualization you can also import. Just click on the import, copy the variable name. So now this visualization is set with this layer. So you find out this type of imagery. Okay. So here you can see we are just use the same function, filter bounds function, mainly where you need the image, then suppose how you need the image, and then when you need the image. Okay, so where, how, and when we are just use and filtering this image collection. After that, we are just use the mosaic using all of images after filtering, and then clip with our study area, and then display our imagery. So this is our imagery. Just use the code. We can easily display our imagery for our study area. Okay, any question? So using the same process, you also try for other image collection. You can see surface reflectance, you also try. Also you can see the Landsat 9, Landsat 7, Landsat 5, or also others you also try. Okay, same process for your study area, you also try for filtering. Okay. Okay. Yeah. Any question, please?
Yes. In the case of that is mosaic, the algorithm not selects the better pixels, right?
Yes. Yes, median it's statistically calculate the middle pixel value and create the composite. But mosaic it's not calculate the any types of statistical value. Just is create the stack. If you check it, suppose what is the mosaic? Mosaic it just composite all the images in a collection using marks. Okay, not apply any kinds of statistical function. But median it apply the statistically middle pixel value, calculating the middle pixel value across all the images. But in this time it not calculate any kinds of statistical value, just using the marks and create this collection composite all the images in a collection. Okay, and return the image. Okay, return the single image. Also median is also return the single image. You can see also image, return the image. Okay, so I have total, before that without mosaic I have total 7 images, but when I apply the mosaic, then this variable stored the single image, it returned the single image. Okay, so that's why size function is not work in here, because size is only work for collection. And if you check, suppose without mosaic, suppose I have a collection, this collection I cannot clip. Suppose if I run the code, it show a problem. You can see it show a problem because clip is always work for the image. Okay, clip is not work for the image collection. If you check the data type in the ee.image, in this section we find out the clip function. If you check the clip function, we find out an clip function. Okay, so clip is only work for the image, but now this variable is not the image, it's just a image collection. So that's why it show this type of problem. Lot of time you face this type of problem for the different function. Okay, for that you simply check your data type, then you can easily get the solution, because now it's a collection but I apply the clip. So that's why it show this type of problem, because clip is only work for image, not image collection. So now I need to create the image. So how I can create the image? I can apply the median, or I can apply the mosaic. So I calculate, suppose put here the mosaic. So when I apply the mosaic, then this variable stored the single image. Okay, single mosaic composite image, then clip is easily work. So now run the code, everything is okay. Okay, okay, so let's go. I hope you can easily get the idea. So using this process you can also try for Sentinel also, Sentinel-2 multispectral instrument. So if you check, so I also show you this process also, how we can easily work with Sentinel-2, but you also try, but same process. You can see the Sentinel-2 surface reflectance or top of atmospheric reflectance, same process, just need to change the image properties. So you can see the image properties, cloud pixel per sentence, okay, or cloud coverage assessment. Okay, also you can see the snippet ID. Okay, also you can see the band name. So you also try. Okay, but I also show you that further class how we can work with the Sentinel. And this type of imagery we can also export. Suppose this type of imagery we can also export from here, and then further we also use in the ArcMap or QGIS software. Okay, for different purpose we need to download the satellite imagery, but Google Earth Engine we can easily download the satellite imagery. Further we also work. Okay, so before that I also discuss about the another data set, suppose modis, then I discuss about that exporting option also. For that modis, if you click on the modis, so modis, it provides the lot of product. This product can be daily or monthly or annually or 8 days. Okay, so you can see different types of product we also find out in here. So all of modis are the same process for filtering. Okay, all of modis, you can see it's provided a lot of data: modis, sleep area index, surface radiation, photosynthetical activity, land surface, PRF daily. Okay, or you can see the aerosol optical depth. There it's provide lot of data. Okay, it's the ready-made product. Okay, so you can easily use, you can say the snow cover daily, or land surface temperature, or land surface temperature 8 day. Okay, terra vegetation indices. So it's provided a lot of data we can easily find out from the modis, and all of data are the same process when you filtering, displaying, and create the map. So if I show you only for the one data, then you try to apply all of data easily. Okay, then you just apply the same process for the different data. So let's go, I will try to show you that one data. I want to show you for which data. Okay, suppose I want to use the data. It's a, I want to show you this process, but this process you can also apply for the other data. Okay, similar process. So this is the one kind of data, just click on here. It's one kind of ready-made data. So you can see it's the MOD30Q1. This is the unique ID. Okay, for the modis, it's one kind of ready-made product. So it provides you the information about NDVI and EVI. Okay, NDVI basically normalized difference vegetation index, and EVI mainly enhanced vegetation index, we find out from here. So now if you check, this data set is very powerful, because this data set is already removed all of unnecessary pixel. If you check, you can see that masked for water, cloud, heavy aerosol, or cloud shadow. So this type of unnecessary pixel already masked or removed from this data set. So that's why when you are using this data, you don't need for filtering image metadata. because you can see all of unnecessary pixel already removed from this data set. Okay, so we find out very neat and clean vegetation map using this data. Okay, even in the more cloudy region we also find out. So let's go, we try to use this data and further we try to create the NDVI map. And if you check, this data set provide the NDVI and EVI, and this is the data set availability time. We find out the data from 2000 to 2025. So let's go try to use it and then check what happened. So just let me open my code editor. So first of all, we need to import the data set in our code editor. Okay, so just copy the snippet ID and paste here. So this data set I imported, then you can put any name as a variable. You can put any name. So I put the name, suppose data set. So now this image collection is stored in this variable, but this image collection have a two bands. If you check, NDVI and EVI. Suppose I want to work for NDVI. So just copy the band name of NDVI and then apply a function. This function called the select function, and select the specific band of NDVI. So just I put the NDVI. After that, this data set is available between this time period, but I want to work for a specific time. So just put here the filter date function. Suppose I want to create the NDVI map in year of 2020, 1st January from 2020 December 31. So in this time, not need to use the filter metadata. Okay, it's not need, because already remove all of unnecessary pixel, not need to filtering. It's one kind of ready-made data. So now let's check how many images are available for the whole world. Just call the data set and then use the size function. So now it's computing how many images are available in this collection. We find out that 23. Okay, 23 images are available in the 1 year, because if you check the temporal resolution, 16 days. Okay, so 16-day global, so 16 into 23, almost we find out the 1 year. Okay, it's the 23 images for the 1 year, because 16 days interval. So we find out this type of imagery. So now if you want, you display the map, just use our map.add layer and call this data set and run the code. So now you can see it added the NDVI map for the whole world, look like that as a gray color in year of 2020. But I want to add the color, so then we can easily identify where the vegetation is better or good or whatever. So just I copy the color code. Okay, in this data set we also find out some color code. You can see, just I copy the visualization parameter, just copy and then paste here. So in this tab you can see basically they are created dictionary. So previous class I discussed about the dictionary. So in this dictionary they are defined the mean value of NDVI, max value of NDVI, and also create the list different types of color plated, color hexacode. This variable just copy and paste after the object name. Okay, then we put the layer name, suppose world NDVI 2020 and run the code. So now it create this type of layer name and also display this type of NDVI map. Okay, for the whole world NDVI map in year of 2020. But I don't need for the whole world, I need for a specific country or a specific area of interest. So for that you can easily import your shapefile in the asset tab, or if you want you can also use the US dataset. So this dataset previous class I already discussed about that. So now from this dataset I just simply filter my specific country boundary. So you already know about that, how we can easily filtering our country boundary. Just take a variable, suppose ROI, and then call the table filter. How I can filter? Earth engine dot filter dot equal what's equal what. Just put here country name I put the country name, suppose Bangladesh. So now this Bangladesh country boundary is stored in this variable. Okay, Bangladesh country boundary is stored in this variable ry. So now I want to display it for Bangladesh. So this is my map. So if I just use the clip function, suppose if you check, suppose I take a variable ndvi, suppose bd, and then call this data set, and if I just clip with my study area, suppose ry, okay, and now I want to display the layer of this final layer, run the code, it show a problem. You can see it show the problem is that clip is not a function. Okay, because this problem, clip, this function only work for image. Okay, but in this case I have a collection, total 23 image collection. So that's why when I use the data set and clip, it show this type of problem. Okay, because clip is only work for the collection, clip is only work for the image. Okay, so now this 23 image collection, anyhow I need to reduce and create the image. So now how I can reduce it? So now we talk about the reducer. Reducer is one kind of statistical function in Earth Engine. If you simply search here reduce, so you can see we are use this type of reducer. So it's one kind of reducer, mean, max, median, mean, mode. So different types of reducer, it's different types of statistical function we are using here for reducer. So if you click on the mean, then check what happened. It reduce an image collection by calculating the mean all of images at each pixel across the stack of all missing bands. In this time it's just only for the one bands of ndvi. So if I just use the mean, then it calculating the average value of all values at each pixel across the stack of all missing bands. In this time basically only for the one bands which is ndvi. So if you want, you can also create the mean, then we find out the average ndvi map. Or if you want, you can also use at the max, it you can see maximum value, then we find out the maximum ndvi map. Okay, maximum ndvi map. Or when I use the mean, then it can compute it the minimum value of each pixel, so then we find out the minimum ndvi map. So different types of reducer we can also use for the different purpose. So now I want to apply, suppose average, I create the average, so then I just need to apply the mean. So let's go how I can apply it. So for that, take a variable, suppose I put the variable name is that mean ndvi, and now I just call the data set, because this data set is stored total 23 images. Just I copy this data set, I want to apply reduce. Then how I can apply? I want to apply ee dot reducer dot mean. Okay, so now further if I just use the clip function in here, just clip with my study area which is ry, then it will be work. Suppose just I display these things, just copy and run the code. So now you can see there is no problem, it also work. And we find out the average ndvi map in year of 2020 in Bangladesh. Okay, any question please? Okay, so when you put the median, then it calculate the middle pixel value of ndvi and display the median ndvi map. Okay, so when you put the max, then it show the maximum ndvi map. So now it display about the average pixel of ndvi map between this year of 1st January to December 2020. Okay, so any country, suppose I put the another country, show the result. So just put the country name, suppose, and run the code. Okay, it also added the layer but not focus. So I want to focus. So for that, just use here map dot center object. Object is RY. I put the zoom level, suppose 8, and run the code. So now you find out this type of NDVI map for Saudi Arabia region, for the whole country of South Saudi Arabia in year of 2020. Okay, so green color is indicating about the vegetation. Or if you want any country, just put the country name, then you can easily find out any country. Suppose I put here, yes please.
Can we use composite instead of reducer?
Okay. So it's one kind of composite. Okay, so in this time it calculate the mean, so it's one kind of mean composite. Suppose in this time I have total 23 images, so it calculate the total 23 images average pixel value. Okay, and create this average NDVI composite. Okay, when you put the yeah, or you can put the median, you can also apply the median, so then it show the median composite of NDVI. So when you put here the max, so then it calculate make the maximum composite of NDVI. When you put here the mean, it computed the minimum NDVI composite. Okay, yes please.
Yes. Why the mean and maximum is 0 and 8,000?
Yeah, I also discussed.
Because
I discussed about that.
IND is 0 to 1, right?
Yes. I also discussed about that after some time. Just a minute. Okay. So now we find out this type of NDVI map, or any country you can simply put, then you can easily get the result. Suppose I put here so we find out this type of NDVI map, but this map have a problem. What is the problem? This problem is that if you check the inspector tab and click on this map, it show this type of pixel number very high. You can see 4,656. So this scale value is not reprojected, so that's why we find out this type of value. NDVI value, always we find out the range. If you simply search NDVI value range, it should be -1 to +1. Always you can see we find out the result -1 to +1, -1 to +1. But now in this case we find out the very high value, 4,000, 6,000, like this. So now how I can reproject it, the scale value of NDVI. So now we talk about that. So it's very important, not only for that, other dataset also in the MODIS, as well as also Sentinel-2 or Landsat surface detectance dataset. You also need to reproject it to get the better pixel value. So now how I can reproject it, the scale value. So for reprojected the scale value, they are already provide the scale number. If you check the scale, this is the scale value. So when I use the scale value in my data set, then this result will be -1 to +1. We find out the pixel value. So now it show the digital number. You can see it show this type of number to -2,000 to 10,000. So this number I need to convert into reflectance value. Okay, so for that I just need to use the scale 0.001. So when I apply this scale, then it show the range -1 to +1, and I find out the correct pixel number of NDVI, because NDVI range always -1 to +1 we find out. So high positive value indicating about the high dense vegetation, low positive value indicating about the low vegetation, and negative value indicating about the water body or others. So let's go try to discuss about that, how we can easily apply the scale value and reproject it, the NDVI range. Yes, please, any question?
Can you please close the secondary window?
Okay.
This one is.
Uh,
Thank you.
okay, so now we discuss about that how we can easily reproject it, the scale pixel value. So let's go.